Hello, welcome back to Piers Rocks. Today we're going to take a closer look at the 28-pin version of One ROM, the most flexible ROM replacement for your retro systems. On the bench in front of me I have a selection of 28-pin ROMs. So this ROM here is a 23-128 ROM chip. This is 128 kilobits, so 16 kilobytes. This is pulled from a Commodore 64C, later Commodore 64, and it's the combined kernel and basic ROM. So the 23-128 was mask programmed at factory. That means it was programmed once and could never be reprogrammed. Next to it I have a 27-128, which is an EPROM. This is erasable, programmable, read-only memory. So this has the same capacity as a 23-128, 128 kilobits, or 16 kilobytes, but it is erasable using UV. So you shine UV essentially through this window here, and it erases the contents of the ROM. It sets all the bits to 1, and then it can be electrically reprogrammed using a programmer like this, which connects to my PC using USB. We'll see that in action a bit later on. And then this final example here actually is a PLA from a Commodore 64, and it has heat sinks stuck all over the top of it. The PLA on a Commodore 64 is a programmable logic array, and essentially took a whole bunch of inputs, I can't remember if it was 15 or 16 inputs, and has 8 outputs, and is essentially used by the Commodore 64 to change the way the machine works based on the state of various different lines on the system. So while this is a programmable logic array, this can be replaced by an EPROM, although only EPROMs that are fast enough tend to work in the Commodore 64. On the left hand side we have One ROM Fire. So this is based on an RP2350 microcontroller. This can emulate all of the ROMs that we see in front of us, and in fact all of the different types of 28-pin ROMs, because as well as the 128 kilobit version I've got here, there's a 64 kilobit version in 28-pin, and also 256 and 512 kilobit. That's 32 and 64 kilobyte versions. One ROM here, the single hardware solution, can actually emulate all of the other chips you see in front of you and all of the other 28-pin ROM types. To program One ROM just requires a USB-C cable and a PC, Mac, Linux device. The way that One ROM actually works is it periodically reads the value on the address lines of One ROM, looks up in a table that's loaded into RAM what byte should be served given that address, and then applies that data to the 8 data lines. For the Fire version of One ROM, Fire corresponds to the RP2350. I actually have 2 different algorithms that I can use to serve bytes. I can serve bytes using essentially a CPU algorithm, which is written in assembly code, or using the PIOs, the programmable input-output state machines that the RP2350 supports, combined with DMA, direct memory access. So One ROM 28 actually uses the PIO DMA algorithm because it's much more performant than the CPU algorithm, and that's actually necessary for emulating the fastest versions of the 28-pin ROMs. This 23-128 is probably quite a slow chip. It probably has an access time of 300 nanoseconds. The PLA, or replacing a PLA with a ROM, requires much faster access times, like 90 nanoseconds or 100 nanosecond type access times. And that can be emulated by One ROM Fire when using the PIO and DMA algorithm. Just in case you're not aware, there's also 24-pin versions of One ROM, which is where the One ROM project started. And I have a Fire and RP2350 version. I also have an ICE version here, which is based on an STM32F4 microcontroller. And both of these can emulate the various different types of 24-pin ROMs that were used in these retro systems. That's the 2316, 2332, and 2364 ROMs can also be emulated by One ROM, as well as the 9316 that was used in the Apple II, and probably other types of ROMs as well. I've got an original 24-pin ROM chip in the middle here. This is from an Atari 800. Next thing we're going to do is we're going to read and also program the One ROM 28. And I'm using the One ROM Studio application to do this, which is available for download at onerom.org/studio. The first thing I'm going to do is plug in my One ROM 28 to USB-C. You can hear my PC's detected it. Then in One ROM Studio I rescan and it's detected that a Phi USB is attached. So I can actually analyze what's already on this One ROM 28 by staying with the Analyze tab and selecting Device as my firmware source and then hitting Detect Device. And this has read a bunch of metadata that's written on the One ROM's flash and decoded it. So it's figured out what One ROM firmware version it's running, 0.5.8. It knows it's a One ROM Fire. It knows it's a 28-pin Revision A board, and it knows what the MCU is. There's also much more detailed information provided here. So, for example, I can see the details of the ROM images that are configured here. There's just one ROM image configured on this particular One ROM 28, and it's configured as a 23/128. That's the ROM type, and the image is this is the combined kernel and basic image for a Commodore 64C. So that's what's already installed on this One ROM. Now if I want to change what's on this, I can go to the Create tab. It's already detected information about this board and it shows me the different firmware versions I can select from. Only the latest version, 0.5.8, is supported on One ROM 28-pin version. And then I can go and select the particular ROM config. Now only the ROM configs that begin with 28 are compatible with the 28-pin One ROM. And there's the Commodore 64C version, which is what's already programmed on there. There's also a 1541-2, which also used a 28-pin ROM, which I'll select at this point. I then build the firmware image, and it's actually downloading the ROM images to serve from the internet at that point. It's now built it. It tells me what's in this ROM image, and then I can flash it by hitting the flash button. So I'll do that now. That's now fully flashed. And then if I go back to the Analyze tab and redetect device, it should tell me that a different ROM image is installed. So I've detected that. It knows it's the same firmware version. That's not changed. But if I look down here, it's now got 1541-2 image installed on it. One ROM Studio also allows you to build and flash custom images. So if you want to install an image for a different 28-pin ROM type or a different image contents, you can do that by defining it currently as a JSON file and then selecting that in One ROM Studio by selecting local file. Then One ROM Studio will build based on the images that you've provided, either images stored locally on your machine or at URLs on the internet, which you can go off and fetch. Then it will build the firmware image and flash it automatically to One ROM 28 or One ROM 24, depending on what you have installed. I am adding additional function to One ROM Studio to actually allow you to build those ROM images within the GUI itself, and that'll be much easier for some people than building a JSON config file. There's really two key benefits with One ROM 28 compared to existing solutions. Existing solutions tend to be second-hand, reclaimed EPROMs like this because these aren't manufactured anymore, or more modern solutions based on modern flash chips installed on a PCB like One ROMs to fit in an existing 28-pin socket. But One ROM 28 natively supports all of the different ROM types and ROM sizes. So as well as different ROM sizes, there's also different chip select behaviors that could be configured at factory with these 23 series ROMs. One ROM 28 supports all of those in software, so you just need a single hardware solution. The other benefit is you don't need a programmer like this to reprogram your EPROM. You can just use a USB-C cable into your PC. You also need some solution to erase these chips if you want to rewrite them, and that requires another bit of hardware, which is a UV light box. This equipment is not particularly expensive, and many people will already have this, but it's actually much quicker and easier to reprogram a One ROM than it is an EPROM, even if you have the right equipment, because you can do it installed in the system. So with One ROM installed in the system, with the system powered on or powered off, you can just jack into it via USB-C and then use One ROM Studio to reprogram the device. So instead of showing One ROM working in a retro system, which I've shown many times before, there's other videos of me showing both 24-pin and 28-pin One ROMs working in retro systems. I thought I'd show it working in this EPROM programmer. Now, just to be very clear, One ROM does not support being programmed by an EPROM programmer. The EPROM programmer works by applying high voltages to the EPROM to both erase it and reprogram it. And One ROM will not support receiving those additional voltages. There's even some risk actually reading One ROM with a traditional EPROM programmer, because it can still apply high voltages to some of the pins. But there's a way around that, so I'm going to show you reading One ROM using this EPROM programmer. First of all, I'm going to get it to read this 23128 chip. So I'm going to install that in the programmer, hit read. So that's read the EPROM, and the contents are all F's because this is a blank, an erased EPROM. So now I'm going to install One ROM. Now this is the One ROM I just programmed with the 1541, and it's really important with One ROM that you install it the right way around. Pin 1 is marked like this, and this is where pin 1 should be in the EPROM programmer. It can and will damage One ROM, powering it up with the polarity reversed. While One ROM can be read by an EPROM programmer like this, it cannot be written to by an EPROM programmer like this. The way that this programmer works is it applies high voltages to specific pins to both erase it and then program it with new data. One ROM does not support those high voltages. The address and data lines are connected directly to the RP2350, which has a maximum voltage of 5.5 volts on any pin. So it does not support being written to via this mechanism. Use One ROM Studio to write to it. There's also some danger in reading a One ROM using a traditional EPROM programmer like this, and specifically you have to have check ID unchecked. The way that ID checking works on an EPROM is 12 volts gets applied to A9, and then the EPROM tries to read a couple of different bytes, and a standard EPROM, when it receives 12 volts on A9, will return specific manufacturer and product ID bytes at those locations. One ROM does not support this because, again, 12 volts will get applied to the RP2350. So there's some risk in reading One ROM via this programmer. I also keep pin detect unchecked as well, and that's because the programmer seems to think that the VCC pin is not properly connected. That's pin 28 on these chips. I don't know why that is. I assume One ROM just has some slightly different electrical properties to traditional EPROMs, and that means that it doesn't think that a proper EPROM is connected. But with it installed this way around, with pin detect and check ID unchecked, and with the 27128 selected in the programming software, I can read the contents of this chip. And we can see some data has been returned. And we can see that this does indeed look like a valid Commodore ROM. We have a Commodore copyright statement at the beginning of it. If we scroll through it, we'll also see a bunch of disk-related messages, probably some status messages that the disk drive returns under certain circumstances. So here we have a bit of human readable text in the ROM. I could now use this in a 1541.2 disk drive in place of the original ROM. So how does One ROM go about replacing a Commodore 64 PLA? At its heart, all the PLA is doing is it's taking in various input signals, and based on the values of those input signals, writing out a bunch of output signals. In fact, 8 output signals. So an 8-bit value or a 1-byte value. That's at its heart the same thing that an EPROM is doing. It's receiving a bunch of input signals on its address pins, and it's writing the byte out to its data pins. Now, the PLA doesn't have a one-to-one pin mapping with a stock 28 pin EPROM. That's where an adapter board like this comes in. And this was sent to me by a subscriber, so thank you, Eddie, for this. And this maps the 2 or 3 pins that need to be remapped for the PLA to be replaced by an EPROM to the correct values. And people have been doing this to replace PLAs on a Commodore 64 for years. So long as they use fast enough EPROMs. I don't know what the speed of this EPROM is in front of us, so I don't know if this EPROM would be fast enough to replace the PLA. But instead of putting a PLA in this adapter board, I can put the One ROM 28 in the adapter board and write the correct image to this ROM, which is essentially the equations that were contained within the original Commodore 64's PLA, and then One ROM 28 can act as the PLA replacement. And I released a short last week showing this working. Now, I did have to slightly overclock the microcontroller on One ROM to get the Commodore 64 to run stably with One ROM as its PLA. The stock maximum clock speed of an RP2350 microcontroller is 150 MHz. I clocked it up to 200 MHz, which seems to be well within the capacity of every RP2350 I've tried. And then my Commodore 64 ran stably for many hours. Now, I haven't done much testing of this or with additional peripherals, so it's possible there's some instabilities or some incompatibilities remain. I also haven't spent any time tuning the algorithm to be specific for the PLA replacement. It may be if I do that tuning, then I can get it stably serving a PLA at less than 200 MHz. All of the software and hardware files for One ROM are open source. Link to the GitHub project down in the description. If you want to get hold of your own 28 pin One ROM, then you've got 2 options. Either you can use the hardware design files in the GitHub project to have your own boards manufactured for less than $10 a piece, or I have a batch of One ROM 28 pins on their way from JLC PCB, and I'm hoping to get these listed early in the new year. Link to my online store again down in the description. I hope you found this video interesting and useful. If you did, please do consider sticking around for the next one. Until then, a very Merry Christmas and a Happy New Year to you. Rock on.